Hello, so in today's video, we're going to look at question 5 of the 2022 Edexcel Paper 1 exam. So in some of my previous videos, we've been doing question 1 up to question 4 of this 2022 paper, so the paper 1 pure maths paper. We're now going to do question 5 of this year's paper. So here we go, this is question 5 here. I'm just going to see if I can zoom in a little bit. There we go. Yeah, so we've got the height h meters of a tree t years after it's planted is modeled by this equation there. So h squared is a times t plus b. T is between 0 and 25 years, and a and b are constants. So we've got some information here. So given the height of the tree was 2.6 meters, exactly t years after being planted, and the height was 5.1 meters 10 years after being planted, we've got to find the complete equation of this model, finding the values of a and b to 3 significant figures. So this is basically going to be simultaneous equations in this part of the question. So what we're going to do is just plug in the first piece of information here into the formula that we've got here. So when the height is 2.6, we've got a time of 2 years, so t is 2. So h squared, using our formula, just plugging h equals 2.6 and t equals 2 in, we get this. So a times by 2 and then plus b. So that gives us, so 2.6 squared, 2.6 times 2.6, just using my calculator to do this, 6.76, and that's equal to 2a plus b. So that's our first equation that we get. In fact, what I'm going to do with this is probably just make b the subject of the formula here. So b is equal to 6 points. Sorry, let me rub this out here. I've made a mistake. So 6.76 take away 2a. Okay, so that's the first equation we get. Now let's look at equation number 2 from this second piece of information. So the height of the tree was 5.1 meters 10 years after being planted. So when h is 5.1, so this time your h is going to be 5.1. So using our formula, h squared equals at plus b. So h is going to be 5.1, so square the 5.1 on the left-hand side, and then substitute in t equals 10 on your right-hand side. So a times 10 plus b. So that's going to give you, so 5.1 squared, that will give you 26.01. 26.01, and that's equal to 10a plus b. So you get that equation there. Now, what we know is we know that b is equal to what we've got up here. So b equals this. So I'll call this equation 1, and I'll call this equation 2. So if we just substitute 1 into 2. So that's the reason why I made b the subject of the formula, just so we can substitute the equation 1 into the b here. So that gives us 26.01 is equal to 10a, and then plus b, which is the same as this number there. So plus 6.76 take away 2a. So simplifying this right-hand side, we get 10a take away 2a, that's going to be an 8a. And then plus this 6.76, and then now we can just take away the 6.76 on both sides. So 26.01 take away 6.76 will give us 19.25, and that's equal to 8a. So therefore a is going to be equal to that number divided by 8, and when you do that, you will get 2.40625. So to 3 significant figures. So the question wants us to three significant figures, the values of a and b. So to 3 significant figures, that's going to be 2.41, rounding the 0 up to 1 there, to 3 significant figures. And then to get the b value, we can just use the formula that we've got up here. So b is going to be equal to 6.76 take away 2 times the 2.40625 that we got there. So the exact value of a, I'm going to use the exact value of a. I mean, in the mark scheme, you can use this rounded value. It won't make much of a difference to your answer, so you can just use the rounded value. So your b value, so b is going to be equal to 6.76, and then if we just do 2 times that number, that would give us take away 4.8125, and then 6.76, take away the answer. I get 1.9475. So again, to 3 significant figures. Sorry, let me just make that clearer. That's a 9 there, and this is a 5 there. So to 3 SF, that's going to be 1.9 and then 5. So we run around the 4 up to 5. So therefore, we get the equation. So our final equation, h squared is equal to a times t. So again, using the formula here, h squared equals a times t plus b. So plug in the a, which we know from over here is that result there, 2.41. So h squared equals 2.41 t, and then plus the b, which is 1.95 to 3 significant figures. So that would be our formula, part A of the question. So we've done that part. And then the next part of the question, so given that the height of the tree was 7 meters, exactly 20 years after being planted, evaluate the model giving reasons for your answer. So what we want to do now is just plug in, for part B, plug in that data into the formula that we get here. So we're going to plug in a t value of 20, and we're going to see what that gives us as an h value. So when t equals 20, so the time is 20 years, we'll plug that into the formula. So we get 2.41 times by 20, and then plus 1.95, and then we'll use the calculator to see what we get. So 2.41 times by 20 plus 1.95, so that gives us 50.15, and this is going to be the height squared. So this equals h squared, because remember, that's what our formula tells us. So then what we can do now is just square root both sides. So square rooting both sides, square root this 50.15. If we do that, we get about 7. So therefore, h equals 7.08, and so on and so on. So that is approximately 7 meters. So it's approximately 7 when t is 20. So that's what the model's telling us. Now it says here, so given that the exact height, the height was exactly 7 meters, evaluate the model. So I would say with this one, that's a pretty good model. So therefore, the model is pretty close to the true height. So the true height after 20 years. So true height after 20 years. So it seems like a good model because we are getting a very similar thing to what we wanted to get. So therefore, model, let me rub that out. The model seems pretty good. So the model seems good. So I'll just say something like that with this one here. So yeah, that's the end of that question. So just a question testing whether you can use simultaneous equations and whether you can evaluate whether a model is good or not, just by using your numbers in your formula. So yeah, that's the end of today's question.